Hey yo, what's up? We back, son. You know who it is? Wait, yeah. JOSHABRAHAM. And we're back. We're back with 1 hour. What? 1 hour? 1 hour. 1 hour of pure fucking focus. 1 hour of pure. I forgot the term. 1 hour of efficiency. Pure, efficient task. Oh, that was too much. I know. I know. I know. I know. Okay, I know. You don't have to tell me. So we got drying crystals. We got a lot of stuff. And the what the fuck? Okay. What was I thinking? What was I thinking? I forgot. So when does the lab start? The lab start on third. Yeah, yeah, yeah. 3rd of March. Oh, 3rd of what? 3rd of March. Yeah. 3rd of March. Yeah. What was I thinking? Hmm. Okay. I kinda get it now. Now what? I was wondering how is the section 1 is gonna look like. Section 1 is gonna look like. That is the one we are gonna start with on the first day of the lab. Can you explain the experiment? Section 1. Each student is able to separate three compounds with different solubilities with classical separation techniques. Nishan, hey yo, what's up? Crack a Megamind. I mean, can I blame you though? It's kinda right. The forehead is a bit, it's a bit the Megamind type of shit. Hey, Nishan, I appreciate you for checking out the stream though. I should have been calling, right? Yeah, I should have called. But yeah, let me see. Let me just write the labs right now, like the notes for the labs. Then we're gonna we have classical separation techniques and can identify them. A mixture containing three different compounds. I'm not talking about your hairline out. What I mean is you are a genius. Appreciate that, dog. But okay, I appreciate that, man. I wouldn't say I'm a genius. I would say, a normal human being. But still, I appreciate the compliment, though. What was I thinking? Yep. Cycle. Bicycle. Where you go? External disk. Pixie Takahaga. Okay, yeah, that's the one. That's the one. Mm. Mhm. ഡേ നീ വിളിക്കാന്ന് പറഞ്ഞിട്ട് വിളിച്ചില്ല. I know, right? I am not the. I'm not doing all the tasks I should be doing. But hey, something's gonna happen tonight, though. The past 2 days, I would say, was such a waste. Like what did I do for the past 2 days? Oh, OBS crashed. Just a minute. Just a minute. My laptop is not having it. Like the storage is like 230 gigs of 256 gigs. Yeah. Well, how was the last 2 days? I started watching a little bit of Netflix. I'm not proud, but yeah, it was just basically Rick and Morty. That's the only show I watched. Then I started watching something called uh, Day Job Kendai. Still no hope. I'm still looking though. Yeah, past 2 days was not good. How you doing though? Oh man, the OBS is crashing. What happened, OBS? What's too much? What is taking that much space though? I'm thinking, what should I do? What is happening? Which? Oh, 239. What's taking this much storage? What is taking this much storage? I don't know. Store all the photos? Is it the photos? Maybe. Let me see the iCloud account. No? Still no? Photos off. Yeah, I'm not gonna store photos. ഡേ എല്ലാം കണ്ണൻ തിരിവുകളാണല്ലോ ഡേ ആണോ ഡേ? Yep. Basically, that's the stage right now. It's not doing good. Like, even the laptop is not doing good. The storage is full. I got 5 gigs remaining on the laptop. What is taking this much storage? I don't know. I did not download anything new. And bigger files, I send it to my hard drive, external hard drive. So what is taking up the storage? Application? Which application? Is it iMovie? I don't know. I don't have any sort of games download. What is taking storage? Safari, okay. Safari takes up 6.4 gigabytes. Okay, I get it. Right now, I was trying to upload some videos, and That is kind of taking up the space. Okay. What do I do? Push through. I know. Think about the appropriate methods about how to do the single separation steps that are not described in detail. All required techniques have to be part of the introductory lab course. Write down your detailed procedure into your lab journal. Okay. The soluble components of the mixture is dissolved in 50 milliliter water. Add 1 to 2 drops concentrated hydrochloric acid in order to make sure that the water soluble salt dissolves, and 50 milliliters of MTBE are separated from the insoluble residue after separation of the phase. The soluble compounds are separated via precipitation. What is MTBE? First, this is the first what? This is the first sentence on the instructions for the section 1. Can you let me know what is MTBE, and also could you briefly explain how the addition of HCl results in more dissolution of the salt? What's MTBE? MTBE stands for methyl tertiary butyl esters, an organic solvent that is mostly nonpolar. So it dissolves organic compounds, but not all salts or organic compounds. Do we add the MTBE after? Yep. So, out. It's added after. Interesting. So after you shake your mixture, wait, use to extract the organic compound from the mixture. Why add 1 2 drops of concentrated sulfuric acid? So this helps to dissolve the water soluble salts, especially if it's carbonate or basic salt. Many salts like carbonates are less soluble in neutral water. Adding HCl provides extra H plus ions that react with the salt. Example, calcium carbonate. So it's not help dissolve water soluble salts. Again, what is the property of water soluble salts though? Water soluble salts. Sto bene? Oh, it crashed. OBS fucking crashed, you piece of OBS. I just went to wash my hands and you just crashed, just like that. That's basically it, right? Why add 1 to 2 drops of concept? Yeah, I read that. How it fits in section 1: 50 milliliter of water plus HCl dissolves in water soluble completely. 50 milliliter of MTBE dissolves the organic compounds. So, when you say carbonates, which could be dissolved more in water with the addition of acid, can I say the carbonates are also organic compounds which with the addition 50 ml MTBE? Is also How long is the stream? I should make sure it's 1 hour. 18 minutes. Hey Siri, set a timer for 10 minutes. Carbonates versus organic compounds. Carbonates like calcium carbonate, magnesium carbonate are inorganic salts. Calcium carbonates are inorganic, okay. Because MTB is non-polar and carbonates are ionic. When you add HCl, carbonates react and dissolve in water, forming soluble salts and CO2 gas. So carbonates are fully in aqueous layer, not in the MTBE layer. Organic compounds in this experiment, these things are like benzoic acid derivatives, which are poorly soluble in water, well soluble in MTBE. They go into the MTBE layer, not in the water layer. The organic compounds are not reach. Oh, it's that thing. Wait, I forgot the name, but yeah, I know what it's about. Carbonate salts in water layer solution. Okay, well, what's next? After separation, phases F. Phases are separated. The soluble compounds are isolated via precipitation. The soluble compounds are isolated via. So here at the end is soluble components are isolated via precipitation. So that means they are the salts. New salts form after adding MTBE. Is it that? Is what? Is that? Am I getting something wrong? I don't. What's that sound? Those ads. Fucking ads. The organic compound is dissolved in MTBE, separated from water. Wait. Water soluble compared. Wait, I asked the question. Water soluble compounds have water. Organic compounds are distilled, recover as solid. To recover it as solid, you acidify the aqueous layer extracted from MTBE with your NaOH in your instruction. The organic acid, like benzoic acid, precipitates. They are isolated organic compound, which may be the same molecule as before, just purified. Wait, so isolated by precipitation means you convert the dissolved ions back into solid by chemical reactions. These solids are not the original salts exactly, but the new compounds formed in the separation precipitation step. After precipitation, drying, and weighing, you identify them. No way, that's soluble compounds of the mixture. Soluble compounds of the mixture are dissolved in 50 milliliter water, and so soluble compounds of the mixture. Wait, I need start from. We are adding water and little bit HCl, then adding MTBE at the mixture that contains 3 ARL from somewhere. Hey, yo, what's up? Had my English exam today. Oh, how was the exam though? English should be easy, right? It's not gonna be that hard. From at least that's like the common experience. How was English for you though? Good. That's good. Which what are the other exams? So math is done, English. Now you got science. Intent, is it science or is it chemistry, physics? It went well. That's good. It's English, right? You got for 10th you got science. Is it science or is it like chemistry, biology, math, physics? It's chemistry. Oh, it's still science. Interesting. I thought at 10th they separate. No. Combined. Okay. So how would you say science is looking? So yeah, it's gonna be mainly four exams: social science, science, uh, math, and extra language, right? The regional language. Mm-hmm. Which would be the hardest one after like English. Now you got four more left, which would be, I wouldn't say hardest. It's just you're not that interested one. Nothing is hard. Contains three or three. I would I would also like to hear an explanation on what does this component means exactly. Are we talking specific elements or unreactive compound? Now we have now after adding everything we have two phases with organic dissolved in the AQ phase and the inorganic in the organic solvent. Is that correct? Inorganic in the organic solvent. Would that be a correct sentence? ARL from somewhere. Did you just leave? Oh, it crashed. Okay, it crashed. OBS crashed again. That's good. 1 hour time mark. I'm not focusing on that shit. But what about the third one? Is it dissolved both of them, or is that the one that's gonna precipitate? The insoluble component is thoroughly dried and the desiccated. The dried precipitate is weighed on a balance and density is determined using a picometer. Density is determined using a picometer. Picometer, if I understand, that was the one I used to measure the benzoic acid, crystallized benzoic acid, though. Is it the one? What did I do to get the density now? Yeah, you try to heat it, and the first temperature where it starts to dissolve, then the last temperature where it's fully dissolved, and you figure out the density from there, right? If I understand. Precipitate of the water soluble compound. Precipitate Precipitation of the wait. What does component mean here? A component means a chemical compound, not an element. You're dealing with one inorganic salt and a compound, one organic compound, one insoluble solid. That could be an element, right? Right? Am I wrong though? Hey Siri, set a timer for 27 minutes. They are chemically separate substances mixed together, not reacting with each other initially, so three components equals three different compounds physically mixed. What happens when you add water and a few drops of HCl? Now we have water soluble in organic salt dissolves in the water layer. If it's carbonate, HCl reacts and converts it into soluble chloride. Soluble chloride. What exactly was carbonate though? Was it? Let me think. 20. So CO3. Okay, CO3. Okay. If it's a carbonate, HCl reacts and converts it into an insoluble chloride. Insoluble chloride. The organic compound does not dissolve well in water. The insoluble compound stays solid. So, water soluble inorganic salt. Water soluble inorganic salt. The ionic compounds lacking carbon hydrogen bonds. Oh, there's. Oh, hydrocarbons are basically organic compounds. So, if there's no hydrocarbon or there's no CH bond, then it's. Wait, crucial for industrial. Okay, okay, okay. And I just came across. To let me know. Why is it copying? Distinction from if there's would this be a correct distinction? I need bigger. You're very close and you understand. Ah, shut the fuck up. Further defined as chemical compounds that contain carbon hydrogen bonds do not contain. Okay, so you are correct in the presence of hydrocarbon chain, which is, however, there are a few important exceptions and nuances of this role that you might encounter in your lab work. The simple hydrocarbons, carbon oxides, carbon monoxides, and carbon dioxides, carbides, carbon. Wait, even though they contain carbon as single compounds are traditionally considered inorganic because they have studied as part of mineral chemistry and have simple non-chain structures. Okay, okay, okay. Oh no, what did I just do? The laptop is so slow that is it working? Yep. Carbon dioxide, carbon monoxide, carbon dioxide, carbides, carbonates, cyanides. Yeah, these are not hydrocarbons though. What if there's no hydrocarbon chain? Yeah, right. Yeah, if there's no, then there it's generally true, but we have to be careful. For example, carbon tetrachloride contains carbon and chlorine, but no hydrogen. Even though it has no CH bond, it's still unanimously considered an organic compound. Why? It was synthesized from other organic compounds. It behaves like an organic compound. Flammable, volatile, soluble in nonpolar solvents. Historically, the definition has expanded to include carbon compounds with or without hydrogen, except for the simple ones listed above. Ah, interesting. Wait, carbon, hydrogen, carbon, chlorine. Mm-hmm. Okay. you have you now have water soluble in organic salt. Oh, again, I just lost track of what I was reading. If it's a carbonate, HCl reacts and converts it into soluble chloride. The organic compound does not dissolve well in water. Organic compounds, hydrocarbon chain. Okay, get it, get it, get it. I get it. Just a minute. Fucking IKEA, IKEA, whatever. Ah, come on. Why? Why? Beat goes hard. Oh, what's that? Oh, don't worry. Don't worry about it. Mm. 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 If it's a carbonate, HCl reacts and converts it to insoluble chloride. The organic compound does not dissolve well in water. The insoluble compound stays still. At this stage, dissolved ions in water. Organic compound, mostly still solid or suspended. Insoluble compound, solid. What happens when you add MTBE? Now create a liquid-liquid extraction system. Water layer occurs. Okay, non-polar. Now separation occurs based on polarity. Water layer contains the salt and organic salts. Acid MTB layer contains organic compound because it's dissolved better in non-polar solvent. Third component. So water layer dissolves like polar dissolves polar, right? Or is that the so water is gonna contain Homan P7P sub. What's up? Oh shit. The moment you send me the message, my screen is like OBS crashed. Just a minute. Dalmatian, hey yo, what's up, Dalmatian? It's been a while, right? I did not stream yesterday, but still, we're back. Human P7P, it's the first time you checking out the stream. If it is, appreciate you for checking out the stream, though. Huh, interesting. Yo, Pratish Mishra. Not gonna lie, it's pretty good videos out there explaining math, physics. Those are some cool content. Not gonna lie. Can you type? I can't type. What happened though? Because I'm on my phone. Oh. Oh no. I don't think you should watch stream right now. I don't think. So I have to mute the stream kinda. Well, well, guys, I'm making an AI in Python called ChitCB. What sort of AI though? Like a chatbot? What is smog? Um, it was something. I was supposed to write something. If it doesn't know the answer, it'll go grab the answer from the internet. Yup. That's cool. Now separation occurs based on polarity, water. Third component, the insoluble. Oh yeah, I was looking into so I was gonna contain compounds that are inorganic and gonna contain are you organic one? Could you briefly explain what? Could you briefly explain I'm making it from scratch in Python. Oh shit. So So water is going to contain compounds that are inorganic, and the MTP is dissolving. What makes these solvents dissolve the stuff they dissolve? I would like to know the key difference in how these two solvents dissolve their like and like their polar and non-polar solvents solutes. Right now, I made it have context handling, which is knowing the last few messages of the user. Okay. Accurate. Why water dissolves as inorganic? Polar, slightly negative and slightly positive, and how it dissolves stuff. Water dissolves ionic compounds like salts, sodium chloride, and other polar molecules through powerful force called hydrogen bonding. Okay. Because inorganic compounds are often salts and not or polar molecules. They are like what? They are like water, so they dissolve in water layers. Dispersion force. Okay, wait. Water layer, solvent type, polar, protic. So polar means they have distinct positive, negative, right? It's in beta mode. Understandable. So non-polar aprotic key bonding force, hydrogen bonding strong. What it dissolves: inorganic polar compounds, salts, sugars, acids. Why it forms strong bonds with. So here the water layer, which is also containing a little bit of acid, and the solvent that are gonna be dissolved. No way, 27 minutes? I'm not fast enough. I'm not fast enough. Come on. Dissolved in it are also having partial negative positive charge within the compound, and it forms bonds with the water molecules like positive and negative interact, or chemical terms, ionic or dissolve into. What should I say to be exact? Can I say ionic salt? Oh, shut the fuck up. The magnet analogy is correct. You are right. When compound dissolves in water, it's exactly like magnets sticking together. The positive and negative attraction pulls the compound apart. If it's salt or okay, compound or negative end of the water molecule is attracted to the positive part of the compound. Positive ion. Positive end of the water molecule is the hydrogen, right? Yeah. What is the exact form for thing dissolving? You asked if you call it or something else. It depends on what type of compound it is. The compound made of metal or non-metal held together by positive negative charges. It's perfectly correct to say ionic salt or ionic compounds. For example, water lake contains an ionic. Is it a polar molecule but not salt? A molecule made of non-metals or share electrons unevenly, creating positive and negative ends like magnet does not break apart, but sugar, the acid you mentioned. Uh-huh. How it dissolves. The water surrounds the molecule because it is porous, but the molecule stays intact. For these polar organic compounds. Uh-huh. Okay. Well, where's the table? So, okay. I understood how the dissolution in aqueous solution works, but there's no driving force in MTB as now. How is this one gonna dissolve? Polar, non-polar dissolved. The magnets are turned off. Let's look at the forces in water. For yeah, the forces are very weak. Called under dispersion forces. MTV molecules are barely attracted to each other. The mechanism path of least resistance. Imagine you have a test tube with three things: water, an MTBE, weakly attracted to itself, strongly attracted to itself. Compound X. Compound X tries to dissolve in water. For compound X to dissolve in water, the water molecules would have to move apart to make room for X. The problem: water molecules are strongly attracted to each other, forcing them to apart to fit X, which they aren't attracted to, requires a lot of energy. It's like trying to force magnet to pull away from another magnet. Result: the water rejects X. It's energetically too expensive. The water molecules would rather stay tight. Okay. If the bond compound X tries to dissolve in for compound X to dissolve in MTBE, the MTBE molecules have to move apart to make room. Not strongly attracted to each other, they are held together by very weak forces. It takes almost no energy to pull them apart. The result: MTBE molecules happily move aside. There is no energetic cost to letting compound X in. Okay, I kinda get it. The real driving force: entropy, the love of chaos. Once the MTBE molecules have moved aside, which is easy, it happens to In its pure form, like a drop of oil, compound X molecules are stuck together, and when they enter MTB, they get to spread out and bounce around randomly through the entire solvent. They go from being stuck in a clump to being free in a sea of MTBE. This increase in randomness or disorder, called entropy, is the fundamental driving force of the universe. Things normally tend towards a state of great disorder. Therefore, the driving force in the MTBE layer is low energy cost. Hmm. So, low energy cost. Wait. So, the organic compound dissolved in MTBE because uh, MTBE compounds, or the, how do I say this, single unit in the MTBE is attracted to each other by London force, which is not that strong. So when some other organic compounds come in, uh, it's not that hard to. Uh-huh. So okay, I kind of get it. Okay, could you let me know why why is the organic compound, why is the organic compound um, by water, or why is water repelling organic compound? I know water molecules are attached to each other with the positive end to the to the negative end to the positive and end. Mm-hmm. Now what charge organic having that the water just pushing pushing it aside. Stop glazing, okay? I just hate when AI is like, oh, that's the most incredible question you asked. You're thinking in the right direction. Shut the fuck up. Shut the fuck up. The electrically invisible problem. Look at the two types of compounds: water plus side hydrogen, and organic compounds has no positive or negative side. Okay, electrons are shared evenly. Okay. Imagine the water molecules are all holding hands. Yeah. Attempt to solve the organic compound. The water molecules would have to let go of each other's hands to make space for the organic. When organic molecules floats into space, the water molecules look at it and find nothing. There's no end for the water's end to stick to. Okay. Result: the water molecules would rather grab back into each other, where hold on to the invisible. Okay, okay. A hydrophobic effect. The chemists call this hydrophobic effect fear of water because water molecules can bond with an organic molecule. The water molecules actually have to arrange themselves into a more ordered cage around the organic molecule just to keep it there. This ordered cages have lower entropy. Its ordered cage is actually lower entropy than normal liquid water. Nature hates that. Mm-hmm. Okay, okay. Could you explain the two scenarios? Hypothetical one where water is surrounding the organic compound, and the realistic one where the water pushes the organic compound to some corner, and I want to know exactly, or I want to know how is one having more entropy than the other. This is absolute heart of the matter. You are asking about the why behind the what, which is shut the fuck up. Scenario A, hypothetical water need to surround. What happens to? Do we gotta? The water molecules are forced into organized, motionless cages around each of the oil. This is an ordered state for the water. This disordered state. Okay. Oh, bro, some of these songs are so bad. Oh my god. What happened though? What happened, Dalmatians? My chatbot works. I asked it the weather and it gave me the weather in my city. So it can access internet. That's crazy. That's cool. I asked it who is Albert Einstein and it answered the correct. Ask it some basic math questions. How is it, or basic coding questions? How is it gonna respond to that? Contains carbon, hydrogen. Ammonia has no carbon but behaves differently. Water is a solvent itself. NH3. Non-polar. Electrically neutral, no strong ends. Has positive and negative ends. Hydrogen bonding, strong attraction, then very weak. Okay, okay. Oils, fats, hydrocarbons. Polar molecules, sugars, and acids. Sugar and acid dissolve now? I guess. Driving force for dissolution. Dissolving in water. Dissolving in MTBE. In Delphi, strong attraction between water and solution releases energy. No energy cost to separate solvent and solute gains freedom. Water molecules pull the solute apart using magnetic attraction. Yeah. Inside little solute in. Water pushes oil away so water molecules can be free and disordered. This is high entropy good. Mm-hmm. Water pushes away something that's polar, non-polar, because it cannot connect or yeah. So it tries to just ignore it. Let's assume a closed container under 0 G's. There's both water and oil. It should basically look like, after a while, it should look like both separated from each other. Like and each should repel what's the problem? Do I know if the AI is They will form a blob inside a sea. What? Ugh. Hmm. Okay. It depends on the. Okay. Okay. I'm gonna end the stream because it's a 1 hour session. It should be 1 hour. I'm gonna end the stream. The next session would be applying for jobs, but before that, let me put the rice in the oven though. Yeah, I gotta cook something. I gotta steam my face. Some stuff to do. I gotta put the rice in the rice cooker. Well, I'm gonna end the stream, gang. We'll be back.